Welcome back to the deep dive. Today we're getting into something a bit different, a real case study in pure utility. We're going hyper-specific. The topic is the NTI, let me get this right, SE-15V-2-2U1C-TTL VGA video switch. That name, it just screams industrial compliance form, doesn't it?
It really does. And the first thing that jumps out at you, beyond the name, is the price. $185.
For a VGA switch in this day and age.
Exactly. And that price tells you everything. This is not consumer electronics. This is infrastructure. It's built for a very specific purpose.
Okay, so that immediately brings up a question for me. $185 premium. I mean, the name suggests it's just a simple switch, one computer, two monitors. Where does it fit?
Well, you're right, but that's not the whole story. You think of it more like a building block.
A building block.
Yeah. This specific model does that simple job, but the hardware itself is designed to be scalable. The documentation shows you can link them, connect up to, I think, 16 computers to a single screen. It's a node, not the central hub. Right, a robust node.
Yeah.
So if we're talking scalability, what kind of performance are we actually locking in here? It's still VGA after all.
You'd be surprised. It's actually pretty robust. It supports resolutions up to 1920 by 1200.
Wow.
And it has a bandwidth of 150 megahertz. This is critical because it means this supposedly old tech can still handle high information displays, conference control panels, medical imaging, that sort of thing.
So the compatibility is pretty broad then?
Oh yeah, PCs, SUNs, MCs, anything with VGA. The real benefit is just getting rid of extra monitors in, say, a crowded data center.
And the physical connections are pretty straightforward.
Very. For this model, you get 2 female and 1 male 15-pin HD connectors. They even include a 3-foot cable, so it's ready to go right out of the box. But here's where it gets really interesting for me, the control features.
Okay.
There's a remote control port. It's a female 9-pin D connector. But it doesn't use a modern IP address or anything like that. It uses TTL. Hang on, TTL. Transistor logic. That sounds incredibly basic. Why would such a high-end piece of hardware use that?
Because in industrial automation, simple is always better than sophisticated. Always.
How so?
TTL and contact closure are just basic digital on-off signals. They give you guaranteed control that doesn't depend on a network. Imagine you're on a factory floor. You can't risk network latency. You need direct, reliable wiring. That simplicity is its biggest strength.
And that simplicity, that basic control, I'm guessing that fits directly into its most impressive spec, the reliability.
You got it. The mean time between failures, the MTBF, for this model is a massive 87,616 hours.
Wait, what is that in?
In years.
It's almost 10 years. 10 straight years of continuous 24/7 operation. It's designed for places where failure just isn't an option. Classrooms, boardrooms, mission control.
And I see they made it easy to live with, too. Hot pluggable monitors, optional audio.
And it barely uses any power, just 5 watts. Plus, it has all the certifications you'd expect, TAA, CE, RoHS, and a 2-year warranty. It's a complete package. So, to sort of wrap this all up, we've decoded this thing. The key takeaways are, well, high-resolution support at 1920 by 1200.
Yep.
That insane 10-year MTBF for reliability, and this very specific, very direct TTL-based remote control.
And that's really the insight, isn't it? This device isn't meant to work alone. It's a component in a much larger system, probably working with other niche hardware like a VGA EDI and emulator. So it leaves you with this final question to think about. What kind of highly regulated critical application would need this exact combination of legacy tech, bulletproof reliability, and non-network control? Maybe something like air traffic control or a nuclear facility console. And that's where a spreadsheet in a box like this really shines.